Hello and good morning, everyone. We are Group 13, and today we are presenting our systematic literature review on artificial intelligence AI security, covering research from 2021 to 2025. Next slide. So this is our team member. I am Safwan Irfan, and joining me today are my colleague Shazani, Nabahan, Nazwa, Muaz, and Nick Daniel. So we have synthesized 15 academic study to bring you an overview of emerging technique and the critical challenge in this field. I will pass the floor to Nazwa to introduce the core concept.
Okay, so thank you, Safwan. So firstly, AI has become a cornerstone of modern cybersecurity, especially when it comes to enabling automated real-time threat detection and response. Today's security environments generate an enormous volume of data, and AI allow us to process this information faster and more accurately than traditional systems. However, we also encounter a critical duality in its adoption. AI serves as a powerful defensive tool, but at the same time, it introduces new avenues for exploitation. In other words, the same technologies that strengthen our defense can be also targeted or manipulated by adversaries. While AI significantly enhances organizational resilience against cyber threats, it simultaneously presents new risks that must be carefully managed. These risks are becoming more pronounced as AI models grow complex and deeply integrated into security operations. In our review, we identify several key of adversarial threats such as evasion attacks, data poisoning, model inversion, and the emergence of AI generate or AI evasive malware. This represents some of the most pressing challenges facing AI-enabled security system today. Addressing this double-edged nature of AI central to our work. It is formed the foundation of the analysis we present in this study. So I will pass to Shazani Sufi.
To address this duality, our review was guided by three main objectives. Objective one was to provide a structured overview of AI application in cybersecurity. Objective two was to critically analyze the vulnerabilities and limitation of the systems. Objective three was to identify research gaps and propose future direction. We examined 15 academic studies published between 21 to 25 using major databases like IEEE, Explore, and ACM Digital Library to answer our guiding question regarding emerging technique and challenges. Next, I will pass to Muazzuddin.
Thank you, much, Shazani. Moving on to the core of our findings, let's look at how AI is transforming the security landscape across several key areas, which is detection, risk and vulnerability, intrusion detection system, which is IDS, and cyber threat intelligence, which is CTI. First, in the realm of detection, we see AI moving beyond simple rule-based checks. It is now actively used for phishing and malware detection by analyzing complex text patterns to flag malicious content. Next, regarding risk and vulnerability, we are seeing a shift to the automation. Our review highlights systems like Autovast, which leverages deep learning to perform automated vulnerability analysis, helping organizations identify weaknesses more efficiently. However, the most significant and vast advancements we found are intrusion detection system, which is IDS. We found that researchers are using generative adversarial networks or GANs to generate synthetic data. This is a game changer because it improves the detection of rare attack type that are often difficult to spot with limited real world data. Furthermore, The integration of SSL, which is self supervised learning, is making this system more robust, helping IDS specifically resist evasion attempts by attackers. Finally, AI is enhancing cyber threat intelligence by processing vast amounts of data. AI enables real time response capabilities, allowing security teams to react incident much faster than before. So I'll pass to Nabahan.
Okay. Thank you to Muaz. Okay, next, despite these promising applications, we identify five persistent challenges that continue to limit the safe and effective deployment of AI system. First, adversarial attacks. It is a AI model, especially those based on deep learning, are highly vulnerable to subtle, carefully crafted manipulations. This attack can cause a system to misclassify information or behave unpredictably, even when the changes to the input are almost invisible to humans. For example, a modified image of a stop sign could be interpreted as a speed limit sign by an autonomous vehicle. This vulnerability shows that AI does not understand the world the way humans do and therefore requires tailored defensive strategies such as adversarial training, robust model architectures, and continuous monitoring of deployed systems. Without this safeguard, advers, adversarial attacks pose real risk to safety critical environments. Second, lack of explainability. Many advanced AI models act as black boxes. They generate output, but it is difficult to trace how or why those decisions were made. This become a major challenge in sector like healthcare, finance, and law enforcement, where accountability and transparency are essential. If a diagnosis system recommends a particular treatment, doctor must understand the reasoning behind it before trusting the system. The absence of explainability not only undermines user confidence but also complicates regulatory approval and ethical oversight. So for the third one, significant computational cost. Training state-of-the-art models, especially large transformers, requires massive computational resources, including high-performance GPUs or specialized hardware. This creates a substantial financial and environment burden. Organizations with limited budget may struggle to develop or adopt these models, ultimately widening the technologies gap between well-resourced institutions and smaller players. Even after deployment, using these models at scale demands considerable energy, raising sustainability concerns. Next is data privacy risk. This technique, such as model inversion attacks, can extract sensitive information from trained models, potentially revealing personal details that were never meant to be disclosed. This is especially concerning in domains involving medical records, financial data, or private communications. Even when datasets are anonymized, AI models can unintentionally memorize and leak identifiable patterns. As a result, developers must incorporate privacy-preserving methods such as differential privacy, federated learning, and secure data governance to protect users from unintended exposure. And then for the last one is ethical concerns regarding the data ownership. So one emerging concept is that of digital doubles, where AI systems learn so much from an individual's data that they effectively create a digital representation of that person. This raises difficult question: who owns this representation? How should it be used? And what side does the individual have over data derived model built in their likeness? Without clear ethical and legal framework, the risk of misuse or exploitation becomes significant. So that's all from me. I will pass to the next presenter, Nick Daniel.
All right. Thank you, Nabahan. And and we will be covering research gaps and limitation. So our review highlighted significant gaps in the current research, where firstly, prioritize explainable AI. We need to move beyond black box model. Security analysts need to know why a system flag a threat. Developing XAI trust, which is explainable AI, and developing as AI builds trust and enables a much faster, more informed response. Next, standardized data. We need to create collaborative global dataset that are challenging and relevant. This must be intentionally populated with adversarial examples and zero-day attack patterns to properly stress test new defense. Oh, my bad. I was reading the wrong one. So let's start again. Research gaps and limitation. Firstly, is outdated dataset where our current benchmark are often decade-old. Datasets like NSL KDD simply don't capture modern threats, things like fileless malware and complex APTs. Next is theory versus practice, where we have brilliant theoretical defenses, but they often struggles outside the lab. We lack the empirical validation needed to prove that the defense works robustly in a live operational environment. We need to close the gap between the academic paper and the deployed solution. Next is the resource inequality. The cutting edge of AI security is computationally expensive. This high demand restricts breakthrough research to only the most well-funded institution. This resource divide slows overall innovation and leaves smaller organizations behind. And lastly, underdeveloped regulation. Finally, we are running headfirst into a regulatory void. We urgently need to create policies on issues like AI-generated deepfakes and the ethics of data ownership. The technology is moving faster than the law, and that creates uncertainty and risk. Okay, next slide. And to address this gap, we propose the following future direction. Firstly, prioritize explainable AI XAI, where we need to move beyond black box model. Security analysts need to know why a system flagged a threat. Developing SAI builds trust, enables a much faster, more informed response. Next is standardized data. Let's create collaborative global dataset that are challenging and relevant. This must be intentionally populated with adversarial examples and zero-day attack patterns to properly stress test new defenses. Thirdly, bridge the gap. It's time to take conceptual frameworks out of the lab. We need to run pilot projects in high-stakes real-world sectors like finance and energy to prove that our defenses are truly resilient. Next is democratize security. We must find ways to make advanced defenses accessible to everyone. Research into lightweight methods like federated learning and edge AI will lower the computational barriers, making state-of-the-art security available to smaller organizations. And lastly, establish global governance. Cyber threats are borderless, and our response must be too. We require cohesive international frameworks to ensure transparency, fairness, and resilience as AI-based security is deployed worldwide. And I will be passing to the last presenter, Safwan.
Thank you, Nick Daniel. For the conclusion, AI security demand robust security first approach and interdisciplinary collaboration. Future work must prioritize explainability, ethical governance, and robust adversarial defense. So lastly, the goal is to ensure trustworthy and resilient AI deployment in cybersecurity infrastructure. Next slide. That's all from us. Thank you for your attention.
Thank you. Bye bye.